This algebra lesson is going to look at probability without counting, and basically the idea is that we're going to be looking at some probability examples with geometric shapes or area. The big idea is that the probability that a point lands in a particular region can be calculated by taking ratios of measures of regions. So oftentimes probability problems involve what is the probability that you draw a certain name out of a head of 50. Those are counting problems. Here we're dealing with area of measures of regions, so we're going to look at some different area models and setting up ratios that way. When a situation has equally likely outcomes, the probability of an event is the ratio of the number of outcomes in the event to the total number of outcomes. But sometimes the number of outcomes is infinite and not countable. In such cases, probabilities may still be found by division. So those two ideas are very important here. Let's take a look at an example right off the bat. Suppose a dart is thrown at a 24-inch square board containing a target. The radius of the circle is 3, as shown at the right. Assuming that the dart hits the board and that it is equally likely to land on any point on the board, what is the probability that the dart lands in the circle? So what we need to recall is that the area of a circle with radius r is pi r squared. And so what we're doing is we're taking the radius of 3, we're squaring it, and we're getting 9. And so the area of the circle is 9 pi. The area of the square is 24 times 24, which is 576. So the denominator is the total outcomes, or the entire region of 576. The numerator is just the circle, which is 9 pi. So the exact probability would be 9 pi divided by 576. If we put that into decimal form or percentage form, it would be about 0.05 or about 5% chance. Now in actuality, if somebody has skill, they're going to probably have a higher chance of hitting the yellow circle than 5%. So the general formula for probability with geometric regions is that the measurement of a region in the event is the numerator, the measure of the entire region is the denominator. So numerator is basically the region of interest, or the focus. In the last example it was the circle. The denominator is the entire region. In the last example, the square, the 24 by 24 board. That was a two-dimensional example. What if we had a one-dimensional example? So we have points A, B, C, D, and E below, representing exits on an interstate highway. And so the distance is given algebraically, W, X, Y, Z. And so the question is, if accidents occur at random along the highway between exits A and E, what is the probability that when an accident occurs, it happens between exit C and exit D? What we want to do is look at exit, the variable that represents exit C and D, and that would be Y. So Y would be my numerator. My denominator has to be basically the entire region, or the entire length. In this case, it would be W plus X plus Y plus Z. That would be my algebraic probability for this example. Let's take a look at another example. Takes a little bit more work. What if I have a target that has 3 evenly spaced concentric circles, and a point is selected at random from inside the circular target? What is the probability that it lies in the red region? The first thing I need to do is figure out what the red ring equals. So I have to figure out the red circle minus the white circle, because then that would be the event that I would be looking for, the event of interest. And so the red circle, or the red ring, rather, equal to 4 pi squared the red ring is equal to 4 squared pi minus the white circle, which is 2 squared times pi. And so that would be 16 pi minus 4 pi. And so the red ring is equal to 12 pi. That would be my event of interest. The red ring would be 12 pi. The entire circle, if you add up all the 2's, that would be your entire radius, which would be 6. So the entire circle would be 6 squared times pi, so 36 pi. And so writing my ratio would be 12 pi divided by 36 pi. And so that would reduce to 1/3. I have a 1 out of 3 chance of hitting the red ring. And that's it for this lesson. Thanks for watching.